We start off with our fourth and final class of trigonometric function. Now before I start, let me just tell you, I want to wrap up the whole chapter in this class itself. So there are two topics to be discussed in today's class. And before I go on discussing the topic of the day, let me just take a few problems from the previous topic, that is the transformation formula, and quickly solve them. Now in case you have understood, no problem, but if you haven't followed, then definitely it will help you out to solve the problems of those particular types. So let us quickly take the problems. So let us take the first one. The problem is cos of 7x plus cos of 5x plus cos of 3x plus cos x, that is equals to 4 cos x, cos 2x and cos 4x. So let us start off with the left hand side. So left hand side is this. Now what to do? We can take two at a time and use the transformation formula, that is cos c plus cos d. Now let us take cos 7x and cos 5x and separately cos 3x and cos x. So if we do so, this is what you get. So 2 cos of 7x plus 5x by 2, cos of 7x minus 5x by 2 plus 2 cos of 3x plus x by 2 and cos of 3x minus x by 2. Now if you just simplify it, this is exactly what you get: twice of cos 6x into cos x plus twice of cos 2x into cos x. Take 2 cos x common, and then again you have another cos c plus cos d. Apply, and this is what you get. So now if you just simplify it once more, you will get this. So simple enough. You have to understand where to start off. Now you can randomly choose any two and start. It will still give you the same answer. Not a problem. Let us move to the next one. Number 2, that is your cos 52 plus cos 68 plus cos 172 degree, that is equals to 0. So once again we are going to do the same thing, taking two at a time. We have to apply the formula. So here we have 3, so let us take the first two. So if I take the first two, I have this: 2 cos 52 plus 68 by 2 cos 52 minus 68 by 2 plus cos of 172 degree. Now 52 plus 68 is 120, divided by 2 is 60, and 52 minus 68 is 16, divided by 2 is 8, rather minus 8. Cos absorbs the negative sign, so it will just give you 8. And 172 degree, you can write it as 180 minus 8. So this is what you get. Then cos 60 is half basically, so 2 into half, that is cancelled, and you are left with cos 8. And cos of 180 minus theta, that is minus cos theta, so you will get minus cos 8, so they both cancel and you get 0. Fine. So that's it. Next, number 3 or number 0, whatever you say. Cos 10 into cos 30 into cos 50 into cos 70, that is 3 by 16. So we take up the LHS. So this is your LHS. Now cos 30 is the standard value which we already know, so we can just write the value directly, that is root 3 by 2. Cos 10, cos 50, cos 70. Now cos 10, that can be, now what we can do, we can multiply a 2 and we can make it root 3 by 4 into 2 cos 10 cos 50 cos 70. Now obviously keep cos 70 out, you can just apply it on cos 10 and cos 50. So twice of cos a cos b is cos of a plus b plus cos a minus b, so this is what you get. Then again cos 60 is half, so if you just put it, this is what it becomes: multiply root 3 by 4 and 70, so you will come up to this step. So root 3 by 8 cos 70 degree plus root 3 by 4 cos 40 and cos 70 degree. Then in the second term, what we can do, we can apply the same thing by multiplying a 2 in the numerator and the denominator. So that is exactly what we have done. Then obviously if you just do it once again, you get cos of 110 degree and cos of 30 degree. Now cos of 110 degree can be written as 180 minus 70, and cos 30 is root 3 by 2. So if you just break it and multiply, you have 3 by 16, and 180 minus 70, that is cos of minus cos of 70, so they both get cancelled and you are left with the answer. Fine. Just go through it once. Next, now we start off with our class. Now what we have is multiple angles and submultiple angles. These are the two topics that which we are left to complete. Now there would have been more topics if we would have had the full syllabus, but as we don't have, fortunately or unfortunately, so here only we have to finish the chapter. So now what is the meaning of multiple and submultiple angles? So let us understand that. Now if we have any angle given, so multiple would obviously mean any integral multiple of that angle. So if x is the angle, then 2x, 3x, 4x, 5x, whatever it is, that is your multiple angle. And submultiple means any integral quotient. Integral quotient means it can be x by 2, x by 3, x by 4, and so on. So they are called the submultiple angles. Now let us first understand the different formulas that we have for multiple angles. Now let us start off with the first one, and I will try making you understand how it happens. So sine 2x, sine of 2x, that is sine of double the angle, that is twice of sine of the angle into cos of the angle. Now it is easy to see why this is happening. So if I have sine 2x, I can write this as sine of x plus x, right? Now if I apply the compound angle formula, so sine of a plus b is sine a cos b plus cos a sine b. So in both the cases a and b are equal, so sine x cos x plus cos x sine x. Now both are equal, so therefore it becomes twice of sine x cos x. I think this is pretty easy to see. Now following this same order, if we just go on, then we have several formulas to come across. I'm not proving them. You can go through the proof if you want. Easy to prove, just applying the compound angle formulas, you can find them. Now we have cos 2x. Now cos 2x has got multiple variations, so you can make use of any of the three, whichever you want. Cos 2x is cos square x minus sine square x. That can be also written as 2 cos square x minus 1, or it can be written as 1 minus 2 sine square x, whichever one of the three. Then I have 2 cos square x. Now definitely this is basically whatever we have in the second one. It is just a corollary of the second formula. So if you just take 1 on the other side, you get 2 cos square x equals to 1 plus cos 2x. And similarly, you have 2 sine square x, that is equals to 1 minus cos 2x. Then we have tan square x. Now obviously tan square x is pretty much, it is coming from 3 and 4. If you divide 4 by 3, you get tan square x, that is equals to 1 minus cos 2x by 1 plus cos 2x. Then tan 2x formula, 2 tan x by 1 minus tan square x, easy to see why. If you just put it in tan a plus b formula, you get it. Then I have sin 2x formula in terms of tan, and it can be written as 2 tan x by 1 plus tan square x. And again we have cos 2x formula, that is 1 minus tan square x by 1 plus tan square x. Okay. Number 9, now this is 3 times the angle. Sin 3x is 3 sin x minus 4 sin cube x. Again, you can prove this using compound angle. If you just work out a little bit, you can do it. Then cos 3x, 4 cos cube x minus 3 cos x. And finally, tan 3x, that is 3 tan x minus tan cube x by 1 minus 3 tan square x. Now these are all standard formulas, can be used without proof. Now if I go on doing the same for submultiple angle, now understand what happens for the submultiple angle. Let me just make you understand on one. Now this 2x here, if I want to make it as x, then definitely this x will become x by 2 and this x will also become x by 2. So basically multiple angle formulas and submultiple angle formulas are same. There is no difference in it. It's just that in one I am writing in the multiples and in another I am writing in the submultiples. So that's it. Basically that's how the formulas are. So instead of remembering them separately, you can remember any one of them and you can just apply it accordingly in case of multiple as well as in case of submultiple. So basically if I go on changing it into the submultiple form, this is what happens. So basically what was the multiple angle formula? Sine 2x is equals to twice of sine x cos x. So here it will be sine x, that is equals to twice of sine x by 2 cos x by 2. So whatever the angle is there, you just divide it by 2. That's it. That's what. And in case of 3x formulas, you just divide it by 3. So that will just give you the formula, right? Now if you can't see this, let me just magnify this. So this is how the formulas are. So sin x is 2 sin x by 2 cos x by 2. This is cos x is cos square x by 2 minus sin square x by 2. That is twice of cos square x by 2 minus 1. 1 minus 2 sin square x by 2. And so on. These are the formulas. You can always find them in a book. It's better to have it written at one place, so that will help you out. Now that's it. That is all about the formula. So we have to just move into the problems. Let us take the first one. The first problem, that is, if sin x is equals to 2 by 3, find the value of cos 2x. Now simple enough. Sin x is given 2 by 3 and cos 2x. Now definitely you have to remember the formulas. So cos 2x formula is, in terms of sine, cos 2x formula is 1 minus 2 sin square x. Put the value and calculate. If you do so, this is what you get. So cos 2x is 1 by 9. Fine, simple enough. Let us move to number 2. Problem number 2, we have, now it is a little bit blur, cos cube x minus sin cube x by cos x minus sin x, that is equals to half of 2 plus sin 2x. So let us start off with the LHS. This is what given, cos cube x minus sin cube x by cos x minus sin x. Now we know we have to apply a little bit of algebra here. Now what is the algebra? If you remember, x cube minus y cube, that can be written as x minus y into x square plus xy plus y square. This is a very well-known algebraic identity which we have studied in our junior classes. So if I do so, if I have x minus y at the denominator, so in that case this x minus y will get cancelled. I will be left with x square plus xy plus y square. So let me do that. So if I do that, this is what I have, cos square x plus sin x cos x plus sin square x. Then easy to see, cos square x plus sin square x is 1 and sin x cos x is there, so I can multiply half and in 2. So therefore twice of sin x cos x is basically your sin 2x. So this is what you get. Then take half common out and you have your answer. Fine. Just go through it once. Next, number 3. You have 1 plus cos square 2x, that is equals to 2 cos to the power 4x plus sin to the power 4x. Now this problem can be started from left hand side. Yes, you can proceed, you can try solving, you can definitely, you will reach the answer at some point, but it is easier to start from the right hand side. So let us take the right hand side first. So twice of cos to the power 4x plus sine to the power 4x. So cos to the power 4x can be written as cos square x whole square, and similarly sine square x whole square. Now a square plus b square, let us understand once again the identity. A square plus b square, this can be written as a minus b whole square plus 2ab. Just remember, if you can, this is an identity. So basically we are going to apply that. So if I apply this here, what happens? See, 2 cos square x minus sine square x whole square plus twice of sine square x cos square x, right? This is what we have. Now cos square x minus sine square x is basically your cos 2x. This is your cos 2x. So you can write in the next line. Okay, I have first removed the bracket and then I have gone for writing it. So this one, cos square x minus sine square x, this can be written as cos 2x. And twice of sine x cos x, this is your sine 2x. So therefore sine square 2x will become 4 sine square x cos square x. So therefore this part is your sine square 2x, right? So therefore we can write all these. So after doing the changes, this is what you have: 2 cos square 2x plus sine square 2x. Now sine square 2x can be written as 1 minus cos square 2x, that is the general identity. Sine square x plus cos square x is 1, so therefore sine square x can be written as 1 minus cos square x. So therefore sine square 2x can be written as 1 minus cos square 2x. So this is what we can write. And then you can see one of the cos square 2x gets cancelled and you have your left hand side. So this is a reverse proof. We start from the right hand side and we end up at the left hand side. So there will be many such proofs which you will come across where you have to start it from the end to reach at the beginning. Then let us take you to the next one, number 4. Number 4, prove that under root 1 plus sine x by 1 minus sine x, that is equals to tan of pi by 4 plus x by 2. Simple problem, requires a little bit of understanding. So here we are making use of a lot of algebra. As you can see, algebraic identities are being used. So you have to ensure you remember them. Now here, whenever you have an under root quantity, we all know that we always rationalize. So what we are doing, we are just multiplying with the whatever you have in the denominator, we just multiply its opposite in the numerator and denominator. So we have 1 plus sine x multiplied both in the numerator and denominator. So from here I have 1 plus sine x whole square, and 1 minus sine x into 1 plus sine x is 1 minus sine square x, that is cos square x. So if you bring everything out, I have 1 plus sine x by cos x. Fine. Now the trick, see what we can do. Now from here you can make use of all different kinds of process. You can make use of the submultiple angle formula for sine x in terms of sine x and cos x. You can do all those things, but as we are trying to prove it in terms of tan, so let me write sine x in terms of tan, and that is let me just zoom in a little bit. So sine x can be written as twice of tan x by 2 by 1 plus tan square x by 2, and cos x can be written as 1 minus tan square x by 2 by 1 plus tan square x by 2. So this is your formula, so I can write this. Now let us see what to do next. So next step, take the LCM, cancel out the denominator. This is what you get: 1 plus tan square x by 2 plus 2 tan x by 2 by 1 minus tan square x by 2. Fine. Now this is a whole square formula, so 1 plus tan x by 2 whole square formula. So let me just put it in that. So this is what you have, 1 plus tan x by 2 whole square by 1 minus tan square x by 2. Now 1 minus tan square x by 2 can be written as a plus b, a minus b. So 1 plus tan x by 2 into 1 minus tan x by 2. So you cancel it out. So you are left with this 1 plus tan x by 2 by 1 minus tan x by 2. Now we will do a small manipulation here. What is the manipulation? See, the 1 in the numerator can be written as tan pi by 4 because tan pi by 4 is basically 1, and 1 minus tan x by 2 I can think of it as 1 minus tan pi by 4 into tan x by 2 because tan pi by 4 is 1, you can always multiply it or divide it anywhere. So this gives us the formula. This is the compound angle formula of tan a plus b, and hence we have our answer. So a lot of tricks going on here, so you need to just wrap your head around this. Just give it a practice, go on practicing, you will definitely get used to it. I hope it is clear. Next, number 5. Number 5, we have prove that cos 4x that is equals to 1 minus 8 cos square x plus 8 cos to the power 4x. Looks a bit conjuring, but it is not. Let us start off with the left hand side, that is cos 4x. Now cos 4x can be written as 2 cos square 2x minus 1. This was one of the formula, you remember. We just have done it. So this is basically the formula that cos 2x can be written as 2 cos square x minus 1. Now obviously if 2 becomes 4, then definitely here I will have a 2. Always remember, here I have double the angle, then I will have just the angle here. So that's how the formula goes. If I have 100 here, 100x, then here I will have 50x. So just that's how the formula goes on. Okay, so now cos 4x can be written as 2 cos square 2x. So basically cos 2x can be again written as 2 cos square x minus 1. So cos square 2x, that means it's whole square. Now you just break up the whole square. So if you just break up the whole square, this is what you get. So 2 into 4 cos to the power 4x plus 1 minus 4 cos square x. Now multiply the 2. This is what you have. And then plus 2 minus 1 makes it 1. And so you have your RHS. Looks a little bit, complicated, but it is not, basically. Number 6. Cos x into cos pi by 3 minus x into cos pi by 3 plus x, that is equals to 1 by 4 cos 3x. Now this is your one of a kind problem, one of the typical problem of this part of the topic. So we start off with the left hand side, and you can see here that I have cos pi by 3 minus x into cos pi by 3 plus x. So let me multiply a 2 and then multiply a half. So twice of cos a cos b, again that formula. Now this pi by 3 minus x and pi by 3 plus x whole to be considered as a and b. So if you apply a plus b and a minus b, if you cancel it out, this is what you have. Now cos 2 pi by 3 is basically cos of pi minus pi by 3, that is minus half, and cos 2x is as it is. So you have minus 1 by 4 cos x plus half into cos x cos 2x. Then again multiply it with 2 and 1 by 4, twice of cos a cos b formula, put it. If you just do your calculation, you get your result. So I am not explaining every single step, which are pretty basic steps. So just go on, go through it and try solving it once all by yourself. I'm pretty sure you'll be able to. Next, number 7. If tan y is equals to 3 tan x, prove that tan of x plus y, that is equals to 2 sine of 2y by 1 plus 2 cos 2y. Now this is a problem where we are going to solve both left hand side and right hand side separately, and we will come to a similar conclusion. Now tan y is given 3 tan x, so therefore you can say tan x is your tan y by 3. So basically we start off with the left hand side, so tan x plus y, that can be written as tan x plus tan y by 1 minus tan x tan y. Then tan x can be interchanged and it can be written as tan y by 3, and if you do the calculation you get this, so that is 4 tan y by 3 minus tan square y. So keep it aside, we will be requiring it later. Let us start off with RHS once again separately. 2 sin 2y by 1 plus 2 cos 2y. Now sin 2y, you can write it in the form of tan, that is 2 tan 2y. I'm sorry, there is one small mistake. It should not be tan 2y, it should be tan y. Please ensure you correct it. Here it is not tan 2y, it should be tan y. It is a slight printing mistake. It should be tan y. Anyway, so again what we have to do, we have to just take the LCM and cancel out the denominator. If we do so, we will be having something like this. So 1 plus tan square y, 1 plus tan square y will get cancelled, and you will be left with the same value as you have got in the RHS. So that shows that LHS is equals to RHS, and hence your result is proved. Fine. So that's how we do it. Now here in this part of the chapter you have seen that a problem can be proved from RHS side to LHS side. So there can be such problems, and also there can be such problems where you may have to prove the LHS and RHS separately. Next, now last one. Now this is just one of the problems. Now you have already done in class 10 how to use the trigonometric table to find the value of any angle, I mean the sine of any angle or cos of any angle. But now here we are not going to use any trigonometric table whatsoever, so we have to do all our calculation. Now also you have a calculator, you don't require one. So the question is given that cos x by 2 is 12 by 13 and x lies in the first quadrant. So obviously it is very important in which quadrant the angle is. Depending on that, the sin x, cos x, tan x will bear a positive or negative sign. Now as it is in the first quadrant, all are positive, so no problem with that. And I have to calculate all these values. Now it is always easy to calculate cos x. Why? Because cos x is directly represented in terms of its multiple angle. I mean multiple or submultiple angle. So cos x can be written as 2 cos square x by 2 minus 1. So therefore I can directly put the value and I can calculate, and if I calculate, this is what I get, 119 by 169. Now if I know cos x, I can always find sin x. How? Because sin x can be written as under root 1 minus cos square x. Simple enough. So put the value, do the calculation, and this is what you should get. And then once I know what is sin x and what is cos x, then tan x is the easiest one to find. So divide it. This is your answer. So basically that's how you do it. Now obviously this was given first quadrant, so we never bothered with the negative sign. But always remember, if I have any other quadrant mentioned, then in that case we have to ensure that we take care of the sign. Whichever quadrant it is, whichever trigonometric ratio is positive or negative, I have to ensure I take care of that. Fine. So that's it. That ends your chapter of trigonometry. Now obviously there are few more other types of sums which I could have solved, but obviously this got already too big to continue with other problems. But if you find out, please ensure you ask and get it clarified. Thank you.